morning children. Today let us study about ethers. You know what are ethers? Ethers are considered as dialkyl derivatives of water. They are considered as dialkyl derivatives of water, or we can say that they are monoalkyl derivatives of alcohol. That is, from hydrogen water molecule, if you remove two hydrogen atom and introduce two alkyl group, it results in the formation of ethers. Or from alcohol you remove one hydrogen atom and introduce an alkyl group, again you will be getting ethers. Is it clear? So ethers are considered as dialkyl derivatives of water or monoalkyl derivatives of alcohol, or we can say that any compound which contain ethereal oxygen as the functional group. The compound which contain ethereal oxygen as the functional group are termed as ethers. Is it clear? So this ethers we can classify into two, that is simple ethers or symmetrical ethers and mixed ethers and unsymmetrical ethers. So ethers we classify into two, simple ethers or symmetrical ethers and mixed ethers or unsymmetrical ethers. Simple ethers means, suppose if you consider CH3OCH3. In this case, both the alkyl groups represents the same group. Okay, so this type of ethers where R and R dash represents the same alkyl group are termed as simple ethers. Another example you consider C2H5O C2H5. This is again an example for simple ether. On the other hand, if R and R dash represents two different groups, then it is termed as mixed ethers or unsymmetrical ether. That is CH3O C2H5 is an example for mixed or unsymmetrical ether. Is it clear, children? Now let us consider the nomenclature of ether. According to the IUPAC system, we can call ethers as alkoxy-alkane. According to IUPAC, ethers can be termed as alkoxy-alkane. For example, if you consider, it is CH3OCH3. In this case, since both the alkyl group represents the same thing, it is very simple. One of the group, actually the ethereal oxygen should be a part of smaller alkyl group and the other alkyl group will be termed as alkane. Ethereal oxygen should be the part of smaller alkyl group and the other alkyl group will be termed as alkane. Okay, so we can call this compound as methoxymethane. Or you consider another example, CH3O, CH2, CH3. In this case, this ethereal oxygen will be a part of methyl group and the other alkyl group will be considered as alkane. So we can call it as methoxyethane. Is it clear, children? This compound can be termed as methoxyethane. Another example you consider CH3O, CH, CH3, CH3. Now just see, to the second carbon atom of this longer alkyl group, methoxy group is attached. So we should call it as 2-methoxypropane. Is it clear, children? This is how we can do the naming of ethers. Now let us study about isomerism in ethers. Just like alcohols, this one, ethers also shows different type of structural isomerism. And the first one we can consider it as functional isomerism. When we have studied about alcohols, we have seen that alcohols and ethers are functional isomers of each other. So let us consider functional isomerism. In this case, suppose if you take the example as CH3CH2OH, which is an alcohol, and then you consider CH3OCH3. Just see, children, both the compounds possess same molecular formula, but first one is an alcohol and second is ether. The first compound is termed as ethanol and the second one is called methoxymethane. So we can consider that alcohol and ethers, ethers and alcohols are functional isomers of each other. The second type of isomerism possessed by ether is termed as metamerism. That is, in this case, if you consider CH3, CH2O, CH2, CH3, or the metamer of this compound, we can consider it as CH3O, CH2, CH2, CH3. That is, the first one is ethoxyethane and the second one is methoxypropane. But both of them possesses the same molecular formula. Is it clear? This type of isomers in which the compound possesses same molecular formula but they have different alkyl group on the sides of functional group is termed as metamerism. Is it clear, children? The type of structural isomerism in which the compound possesses same molecular formula but have different alkyl group on the sides of functional group is termed as metamerism. So, ether shows two types of structural isomerism, that is functional isomerism and metamerism. Now, let us study the method of preparation of ethers. Method of preparation of ether. First method we can consider dehydration of alcohol. Dehydration of alcohol. Students, already we have studied one method there for the preparation of, when you consider as a property of alcohol, there also you have studied dehydration of alcohol which results in the formation of alkane. In this case, we can say that if alcohols undergoes dehydration at about 413 Kelvin, then it produces ether as the product. Is it clear, children? Alcohols undergoes dehydration at about 413 Kelvin and produces ether as the product. Let us see the mechanism of this reaction. This is the last mechanism we have to study in this particular chapter. So, the first step is protonation of alcohol. That is CH3CH2OH undergoes protonation and produces protonated alcohol CH2OH2 here, which loses a molecule of water and you will get a carbocation. Is it clear, children? In the first step, alcohol undergoes protonation, produces protonated alcohol which loses a molecule of water and got carbocation. In the second step, attack of carbocation on another molecule of alcohol. Attack of carbocation. So we can say that CH3CH2OH plus CH3CH2 will give you an addition product CH3CH2OH CH2CH3. Now just see, children, here you can see that the one hydrogen ion is extra. So the last step is deprotonation. Deprotonation, we can remove one H plus from here, that is CH3CH2OH plus CH2CH3 will loses a molecule of hydrogen ion, that is it loses one proton and produces ether. Is it clear, children? That is how the mechanism takes place. In the first step, protonation of alcohol which results in the formation of carbocation. Second step, attack of carbocation, and third step, deprotonation which results in the formation of ether. Is it clear, children? The rest method we will study in next period.